Good day, everyone. I hope you all had a free lunch. So, I know that this is a first session after lunch, and obviously, not many people will be active. So, and refer to keep this presentation as a little bit heavy on the demonstration, so such that you can say, be awake. So, my title of the session, the title of my session for today is how to build a K3s cluster using Raspberry Pi, where I use Raspberry Pis as my computer of choice and use K3s as my preferred Kubernetes distribution. Now, before we start, I would like to just do a quick raise of hands. So, how many of you here are freshers to 3 years of experience? We total. Great. And how many are more than 3 years of experience? Cool. So I would say the audience is quite young. So I'll keep my the presentation that way. Thanks a lot. So I'll go a bit of intro about myself. My name is Aditya Krishna Kumar, and I'm a senior site reliability engineer at Sentinel One. I have a total of 8 years of experience in DevOps and site reliability engineering. I'll share my social link at the end of this presentation, and then we can connect from there. So let's talk a bit about Graham. So we have many of the Kubernetes clusters that everyone is operating. They are mostly on cloud providers. You name it, like Azure, AWS, or Fukta, or Google. You would generally use these kind of cloud providers to host your Kubernetes cluster. But have you ever wondered what about all the things about compute, storage, and network, which is added there? Like all of the cloud providers that we are using today, they are extracted away these fundamental tenets of cloud computing. So as Casey Hightower has said, that if you want to learn about a particular technology, you would have to go 1 year deeper. So before starting my home lab journey, I was also operating clusters in Kubernetes clusters in cloud providers, and all the things about compute, all the networking requirements, how to provision the storage, all of this were abstracted away for me. So this actually gave me an opportunity to explore further on this on Kubernetes, but more in a 1 year deeper. So let's talk a bit about my mission, like why did I chose to build a home lab, and not just just means simple mini cube or something on my laptop, and hidden the rig. So first thing, so I have few goals here. First goal is I want to have a playground where I want to experiment with things like Kubernetes operators, or distributed storage, for example. So there are many such things which are in Kubernetes which are abstracted away, and you would never know unless you experiment with it. So the second thing is I would talk about networking part. So any of the networking that I have connecting to Kubernetes cluster, I just have my kube config and just connect with it, and I'm done. So I mean, I definitely want to dive deeper and want to understand how the networking is configured. So, and also want to have some a solution where I want to have ad blocking. That's it. That is, as you might know, that we have a lot of ads now who are we are seeing a lot of ads on our personal devices. So I wanted to have a solution where if I connect to it, then I should be able to block all of my networking capabilities. I mean, I should be able to block all of those ad trackers and just have a ad free internet experience. Then other things what I want to have is to own my data back. So any of the, you might have seen the Google One subscription or Apple iCloud subscription. So all of them are charging a few hundred rupees a month just to access our own data that we are owning, right? So I want to take back that ownership. So for that, I wanted to have this solution where I can host all of my code, all of my personal files, everything's on my own storage without having to pay somebody to access those. And and I own the entire like security and end-to-end life cycle as an engineer. So yeah, that is the reason. Yeah, so these are the three goals that I went with to build out my vendor. So this is the Kubernetes cluster itself in the picture. So as you might see, the photos, I just took the photos this morning. So, and by the way, this lab is now and based out of Ahmedabad. So this lab is currently sitting in my home, and I'm accessing. I'll show in the demo part. I'll show how to how I access my applications and everything remotely. So yeah, these are like the pictures of the my home lab. So as you can see, it has like it's a 4 node Raspberry Pi. The bottom one, which is having the red indicator, that's my DNS node. I That's just to handle all of the utilities for like handling all the DNS traffic and locking ads. Then the other 3 nodes which are above that, these are the Raspberry Pi for my Kubernetes cluster, which are essentially like the Raspberry Pi 5 version. And along with that, I have attached 2 hard disks, which are like 512 GB each. So that gives me like a total of 1 TB of storage who play with and configure all the data storage. So yeah, let's talk about the cluster. I mean this entire while lab layer by layer. So first is about the hardware. So as I mentioned, I have a 4 node Raspberry Pi cluster, out of which the 3 nodes are essentially like Raspberry Pi Pi, which is like an 8 GB RAM and 4 core configuration. And along with it, I have a utility instance, which is a Raspberry Pi 3. That was just something which I had lying around from my from my college days. So if I got just reuse it for this particular purpose. And all the connectivity and using an unmanaged switch. The reason I didn't went with a managed switch is because I wanted to optimize my cost. I just wanted to have networking and don't want to have any additional subnets. I'll explain in a bit that how I'm managing my connectivity. Then all of the storage, like I mentioned, I'm using two solid state drives, which are connected via external USB cable. So nothing too fancy, just nodes connected to the disconnected to the node, and then I'm just managing it. The total cost that it came to me when I was building out this RLAT, this home lab 3 months ago, it came out to be 31,000 rupees, which is not too bad. I can this is I would say a starting point. So yeah, all the students out there, you can take this as a you can also end out this kind of like cost effective Kubernetes clusters for yourself. So let's talk about the next layer, which is the operating system. So one of the things which I had faced earlier when I was using Raspberry Pi 3 was the node was taking a long time to get started, and would take around 3 to 4 minutes easily just to get started and have uh, have it ready, just to get a login shell. So I mean, again, the node was also not really performant, but again, I didn't wanted to take chances, so I went with something called as DiPi, which is a variant, it's another like a Linux operating system that I'm using. It's nothing but just your plain old Debian with which has all the components stripped out, and just as some utility scripts just to help me with some various configuration. And the beauty of NightPy is that I get to have all the configuration as headless. I don't really need to have a desktop interface or connect to an SD connect to a moniker to just to complete my Raspberry Pi setup. All of this is headless. I just need to write a file called nightpy.txt that allows me to configure just from just the hostname and static IP all the way to SSH keys and everything. So the moment I plug in my SD card to my Raspberry Pi, the node is itself up and running, and I can just connect it via SSH. plain and second. Now this is again a part of the, I would call it as part of the compute, where I talk about the orchestrator. In this case, as the title of my talk says, it is K3s. Now K3s, the reason why I chose K3s is I've seen testimonials in public and also public use case studies where, you're using K3s on like edge environments. It has been like beneficial. Now this is kind of like simulating an edge environment where it's like, low network connectivity, and it's like, just the compute power is less, comparatively less. So so given all of this, my environment configuration, I went with K3s as my orchestrator of choice. Now there are some few components when it comes to the K3s uh, uh, distribution. So first is it's the entire Kubernetes application, like the entire thing, the API server, uh, the state database, your networking components, everything is packaged into a single binary file with, so such that, so if I want to run a single node K3s cluster, it's like pretty simple to use. I can just install K3s and that as simple application, and my Kubernetes cluster is up and running. Now this is the like, again, this is, I've taken this architecture from the docs, but I'm also following a similar kind of architecture when it comes to my cluster. So here I'm having in my architecture also is having like one server node which contains the SQLite database. So the the state management, you, if you are like learning Kubernetes or have heard about it, you might know that etcd is usually the state management for, like, you use etcd database for the state management. But in the case of KTS, you use SQLite as the state database. Then all of these, the other worker nodes that are part of my cluster, I had them as agent node, which they run in an agent mode, and they just simply have just the runtime library and just the networking proxy for other who handle all the runtime and networking related requirements. Now, all of this configuration, if I want to, have any sort of load balancing or any deployment, then there is a load balancer service. Like it was previously called keeper load balancer, but now it's called as service LB. Service LB, what it does is we just simply runs as a daemon set inside all of your nodes. And when I expose any service as a load balancer service, it simply runs it simply creates port forwarding for that particular service in all the nodes. And whenever a traffic comes in, that is then load balance via the IT tables. So yeah, that's like the gist of the service LB load balancer. Now here's the cluster topology that I previously mentioned. It is having like a single server node. I'm having one server and two worker configuration. So both of these worker configurations, they are like, so all the three nodes, that is master and both the workers, they are 4 core and 8 GB configuration. So I have a total of 24 GB RAM and 12 cores across all the three modes. So yeah, it's like, as I mentioned, that it's, and if you want to like set up any Kubernetes worker, if you want to set up any instance as a Kubernetes as a K3s worker, it's a simple that you run it in an regent mode, and you specify the master IP address as well as the token, and you are good to move. Now let's talk about the third layer, which is the connectivity networking part. So when it comes to networking, I wanted to have like I mentioned with my requirement, that I wanted to access this cluster from any part of the world, no matter like whether I'm accessing it from coffee shop or from from an office. I should be able to access this Kubernetes cluster. So for that, I'm using something called as PayScale. PayScale is it's based on a technology called Wireshark, where it's essentially nothing but a distributed VPN, where you don't have a single you don't have a single centralized node to connect to. If your if your modes are part of the mesh network, then they are easily they are connected to each other with, like, no, so all the necessary like encryption and things like this. And that way you don't have to. So the benefit of this particular solution, Tailscale, is that I get the same Wirecard technology, but I don't have to like manage the control plane myself. I can have this control plane. This control plane lives in Tailscale's environment, and there it uses that for managing, for all the IT management, as well as all the things regarding access policies and everything it does. So yeah, so that's the covers the Tailscale, like the VPN part for the connectivity. And also the free tier is also like pretty generous. It supports 3 users and it supports 100 devices for your mesh network. So it is like, pretty generous in my opinion. Now when you talk about, so now I have my cluster. It's having all the networking configured. I can access it from a VPN and everything. So, but now what about accessing the applications? So I ensured that any application that I deployed in this cluster, I should be able to access it from any part of the world. Okay, cool. I think so. Yeah, as I was continuing further, so as I was mentioning that all of these applications, they are it's running in Kubernetes cluster, but I want to expose them such that I can access it from anywhere, but not kill other users. So for that reason, I don't want to like have open up a firewall, like do some port forwarding and do all of that, because that's like no, it's like another bunch of like security OG only. Okay, so for this, to solve this particular problem, I'm using something called this HCM operator. Now this operator is like just like any other Kubernetes operator. You deploy it via nchart and you have it up and running. But what this operator does is that when you have any app, any ingress or any service with load balance or any other type. Now, if I want to expose this to the world, I mean, not to the world, but expose this, then what I would do is I would just add an annotation for that I want to expose this application. And once the operator sees that this annotation is present, then then it will create a sidecar proxy that will assign a magic DNS, which is something like, it's a tailscape specific like DNS. This is always unique. This is never like, you can't like choose yourself. It's always like auto assigned to you. And that way you get a DNS with which you can access the applications. I'll show about this this bit in a demo. And these applications will only be accessible via once the device is connected to the main. Let's talk about the fourth layer. So any of the DNS, like I mentioned, I want to have a solution which basically blocks all the ad traffic for me once I connect to it. So for that, I'm using something called Pi-hole. Pi-hole is a very popular like a DNS ad blocker where you add all of the DNS entries. I mean, all of the DNS entries of any ad servers or any trackers that you think that is, pitch too pretty. Then you can just add in to the Pi-hole DNS list, and then whenever you do a request via the Pi-hole, then it will lock the DNS entry and will give you an ad-free experience. Let's talk about storage strategy for a bit. So, for example, now when you talk about Raspberry Pis, as I mentioned, you always need an SD card to like configure the file system and configure the operating system itself. But when it comes to like storing the data, you shouldn't be storing it in the no, you shouldn't be storing it in SD cards. Rather, you should offload it away to some external device like an SSD or maybe one like a if you can afford, then a NAS server, network attached storage server. So with that, you should be able to like have many of the persistent data. For example, in this case, I'm taking Forgeo, which is essentially a self-hosted GitHub. Any of that with data and as well as any of the database that I want to try out, all of that data lives in the SSD and not in the SD parts. Now, obviously, I have all of these components. I have all of these applications, configured, all of the storage. I mean, I have a lot of moving parts now when it comes to my own lab. So now I want to have observability for against all of this. Okay, so for that, I don't want to have Prometheus and Grafana pull few Prometheus stack install in my own lab, because that will essentially like bog down my this Kubernetes cluster, and it would essentially be useless to host any of the other applications. So in order to, to offload this, I'm using Grafana Cloud, which is also like a managed service for Grafana, but it is also a generous free tier. It gives you 14-day retention, and it gives you all the things about like, metrics, logs, and traces. So it is like, I would say pretty generous. So yeah, that and I use something called as Grafana Alloy just to run my, my to for all for gathering all the data like open telemetry and everything, and send it over to Grafana Cloud. Let's quickly go over to the demo just so that I can, show you the actual cluster itself. So as you can see, this is the DNS that it's mentioned. This is having some custom domain name .ds.net. Now this is unique to my domain, and this is my like Git repository which I have, where I'm self-hosting some repositories. So let me just quickly log in. Yeah, so it is having all the things about, my application. It's like your full-fledged GitHub and everything. So this is having some, I have some code base from my one of my previous, meetup talks, and I just, upload it here. Now this is the actual Painscale network where where my all of the machines and also all of the Kubernetes operators hang up the operator deploy the Kubernetes ingress. That is accessible via the Tailscale network. So now if I, for example, I have this Kubernetes master. So I want to do SSH here. So I simply click SSH. I select my user. I start the SSH session, and it gives me an SSH right from my browser. I don't have to do anything else, and I get a terminal. Okay. Let's quickly go to the Kubernetes, the Pi-hole, which is my DNS, ad blocker. So as you can see, I am doing a lot of DNS queries. Mostly like my Mac and my mobile are responsible. It shows that what are the DNS queries that were done, how many were blocked, what are the top block domains. As you can see, Google is, very generous with, all the ads that you are trying to search. So no, that, yeah. And let's quickly go with the observability as well. So this is my Grafana Cloud instance where all of my cluster, my data, like my all the cluster observability thing, that is logs, metrics, and traces, all of it is available right here. And I can simply scroll and see that what are the logs that is there, and do queries and do all of the like observability stuff I want to know. So yeah, then fix, quickly jump right to the distribution. So what are the lessons that I learned from from this from this, from my home lab experience? So I would say that setting up resource quotas is mandatory. Now, for example, if you are running something in a namespace and you're not setting up any resource limits, then easily your cluster will get fed up in no time, and you would be having very less, resources to set up the application. Second is we talk about like the architecture. So you need to ensure that whatever images or whatever application that you are trying to deploy, that should be built in ARM64 image format. Otherwise, it won't run. Then third is you need to avoid overloading your nodes, and you should have like the server Kubernetes server node to have it just for your control plane requirements, and nothing else should run on your control plane. Then we talk about, the networking. You should always use wired networking rather than wireless networking, because if there is any Wi-Fi latency, then your cluster will, you know, won't be like in a much stable state. So here are the few key takeaways that you should be taking away from this session. So Raspberry Pi as your own lab environment, that's that gives you best amount of like practical engineering, and deploying open source software is also you get to learn about that. Then do also learn about things like, capacity planning, like what should be the capacity that you do for your application. Also, what should be the network engineering look like I showed, like with the VPN configuration and everything, and also for like system design. So these are some of the key takeaways that you can learn if you are like, making create your own tab on Kubernetes on Raspberry Pi. So I think, yeah, that mostly concludes my session.
Thank you so much for the beautiful session on labbing and respirators. Here's a